Let us take another example. Consider a situation in which in a loop you have certain resistors and certain EMFs. आपको एक लूप दिया गया है in which there are certain resistors. Say this is of 1 ohm, this is of 2 ohm, this is of 3 ohm, and say this is of 4 ohm. Say this is 12 volt and this is 2 volt. In this question, the corner which is here, इस कॉर्नर को आपने ग्राउंड करके दिखाया है. This is already given to you in the question. In this question, this corner has been grounded. What is the meaning of grounded? Grounded means इस पॉइंट की पोटेंशियल जीरो होगी. Meaning of grounding is that potential of that point has been given as a reference to be taken as zero. And let's suppose another point P has been marked here. दूसरे opposite corner में हमने एक point P mark किया है. You have to find out the potential of P. Find the potential of point P. You have to find out the potential of point P. Now see, in this kind of question, जब grounding की बात दी गई है, when you have been given a case of grounding, then first you forget about this grounding. आप पहले इस grounding को भूल जाइए and circuit को दोबारा ड्रॉ करके देखिए कि हाउ डज इट लुक लाइक. इट लुक्स लाइक this. This is the point P. First you forget about grounding and try to look at this circuit. Here this is 12 volt and this is 2 volt. Now you tell me these two cells are connected in series or parallel. आप मुझे ये बताइए कि ये cells series में connected हैं या parallel में. तो remember that these cells are not connected in parallel, they are connected in series because वो एक single loop में है. ये दोनों cells series में ही connected हैं because वो एक single loop में है. Only thing is that this 12 volt has the tendency to flow the current in clockwise direction and this 2 volt has the tendency to flow the current in anti-clockwise direction. ये दोनों cells opposite polarity में लगे हुए हैं लेकिन हैं वो series में. Is it clear? ये 12 volt clockwise current flow कराएगा and 2 volt anti-clockwise. Now which one is dominant? यहाँ पे dominant कौन है? Dominant ये 12 volt है. That is why जो इस पूरी सर्किट में करंट फ्लो करेगी वो 12 वोल्ट के हिसाब से करेगी. दैट मीन्स द नेट करंट विच विल बी फ्लोइंग इन द सर्किट दैट विल बी क्लॉकवाइज बिकॉज दिस 12 वोल्ट वोल्टेज सोर्स इज डोमिनेंट ओवर दिस 2 वोल्ट. इज इट क्लियर? नेट ईएमएफ अगर सर्किट में देखा जाए तो वो 12 माइनस 2 दैट इज 10 वोल्ट के इक्वल होगा. द नेट करंट will be having a direction like this, mind you, and उसकी वजह यह है कि 12 volt dominant है and it has the tendency to flow the current in clockwise direction and दोनों cells series में connected है with opposite polarity. Now substitute the values of resistance. Here you have 1 ohm, here you have 2 ohm, here you have 3 ohm, here you have 4 ohm, and now you tell me what is the value of current flowing into the circuit. Then you will say current is net EMF upon net resistance. Now net EMF, as you said, since both these voltage sources are connected in series with opposite polarity, तो हम कहेंगे इसकी net value 12 minus 2 हो गई. Isn't it? The net EMF is 12 minus 2 volt, that is 10 volt, and since the same current is flowing in all these resistors in a single loop, then we claim that all these resistors are connected in series. हम कहना यह चाह रहे हैं कि अगर सेम करंट आई फ्लो कर रही है सारे रेजिस्टर्स में, तो सारे ही रेजिस्टर्स सीरीज में कनेक्टेड हैं. देयर इक्विवेलेंट विल सिंपली बी द नेट सम ऑफ देम. इनका इक्विवेलेंट सिंपली इनका सम होगा. व्हाट इज दैट? दैट सम इज 1 ohm plus 2 ohm plus 3 ohm plus 4 ohm, 10 ohm total. Now see here, the voltage is also 10 volt and the resistance also is 10 ohm. Therefore, the current which is flowing into the circuit, करंट जो सर्किट में आई आपने दिखाया है वो कितने के इक्वल है? वो 1 एम्पियर के इक्वल है, as it has been indicated by our calculation. You see that? Now you remember that the portion which was grounded, that will come into picture to tell you that this is at zero potential. I have written 0 volt. जो ग्राउंडिंग का पॉइंट दिखाया गया था उस पे कॉन्सेंट्रेट करिए और ये सोचिए कि ग्राउंडिंग का मीनिंग ये है कि इस पॉइंट का पोटेंशियल 0 लिया जाएगा, बिकॉज दैट इज द कन्वेंशन, दैट इज द रेफरेंस. आ रही बात समझ में? एंड अब आप इस पॉइंट से पॉइंट P तक पहुंचने का ट्राई करेंगे. यू विल स्टार्ट फ्रॉम दिस पॉइंट एंड वन बाय वन यू विल रीच पॉइंट P. You have two alternatives. Either you can use this circuit or you can use this circuit. आप कोई भी सर्किट से जा सकते हैं, आपका आंसर सेम आना चाहिए. Now you first apply plus minus sign. Let us suppose I have taken this circuit. Then it is minus here, plus here, because that was the convention. Since current here is flowing in this direction, so this will be plus and this will be minus. Here also the current is flowing in this direction, so here it will be plus and minus. And now you can reach point P. You understand? हमने प्लस माइनस साइन कन्वेंशन के हिसाब से लगाया है. वोल्टेज सोर्स में यहां नेगेटिव, यहां पॉजिटिव, करंट में करंट की डायरेक्शन में पॉजिटिव एंड नेगेटिव, एंड सो ऑन. नाउ यू स्टार्ट मूविंग फ्रॉम दिस पॉइंट. जब आप यहां से स्टार्ट करेंगे तो इस पॉइंट का पोटेंशियल आपने लिखा है 0, सो आई हैव रिटन 0. नाउ यू विल बी जंपिंग अक्रॉस दिस 12 वोल्ट सोर्स. जब आप इस 12 वोल्ट सोर्स के क्रॉस जंप करेंगे, देन यू आर मूविंग फ्रॉम नेगेटिव टू पॉजिटिव, यू आर मूविंग फ्रॉम लोअर टू हायर पोटेंशियल. देन व्हाट विल हैपन? यू विल बी गेनिंग वोल्टेज. आपका पोटेंशियल बढ़ेगा बाय हाउ मच? बाय 12 वोल्ट. आपका पोटेंशियल 12 वोल्ट से इंक्रीज करेगा. एंड नाउ आप यहां पहुंच गए हैं. नाउ यू हैव रीच पॉइंट दिस. नाउ जंप अक्रॉस दिस रेजिस्टेंस. इफ यू जंपिंग अक्रॉस दिस रेजिस्टेंस, then this plus and minus sign is showing that आप हायर से लोअर पोटेंशियल पे जा रहे हैं, isn't it? तो आपका पोटेंशियल डिक्रीज करेगा बाय हाउ मच? बाय I इंटू आर. बाय I इंटू आर. I की वैल्यू भी आपने निकाली है 1 और R की वैल्यू भी वहां दी गई है 1, isn't it? You can see यहां पे आपने करंट की वैल्यू 1 एम्पियर कैलकुलेट की है और रेजिस्टेंस की वैल्यू भी 1 ओम है. सो यहां पे पोटेंशियल का जो ड्रॉप हुआ वो 1 का हुआ, वो हमने यहां पे -1 लिखा है. नाउ यू हैव रीच पॉइंट दिस. अब आप यहां पे हैं एंड आपको लास्ट जंप करना है थ्रू 2 ओम. थ्रू 2 ओम, इन केस यू विल जंप, यू विल मूव फ्रॉम हायर टू लोअर पोटेंशियल. प्लस से माइनस आप जाएंगे, फिर से आपका पोटेंशियल का लॉस होगा. योर पोटेंशियल विल बी गेटिंग रिड्यूस्ड बाय I इंटू आर. फर्दर you can say minus I into R means I is 1 ampere, तो 1 ampere हमने लिखा, into R is 2 ohm into 2, and now you have reached the desired point P, so that will be written as the potential of point P. You understand? This is the way I started from the reference point, that is the point of grounding, from 0 potential, and finally we have reached point P. So if you calculate this, you are getting 12 minus 1 minus 2 is equal to the potential of point P, जो कि इस क्वेश्चन में डिमांडेड था. That potential of point P is equal to 12 minus 3, that is equal to 9 volt. ये आपका फाइनल आंसर हो गया. दिस इज योर फाइनल आंसर. that the potential of point P will be equal to 9 volt. Now what was the use of this grounding point? Grounding point का मतलब सिर्फ ये था कि यहां पे आपको रेफरेंस पोटेंशियल 0 लेना है एंड विद रिस्पेक्ट टू दिस पॉइंट जो भी डिजायर्ड पॉइंट है उसकी पोटेंशियल यू हैव टू कैलकुलेट. नाउ लेट अस टेक अनदर इंटरेस्टिंग एग्जांपल highlighting the grouping of cells. Take another example. In this situation, you have been given that there are a number of cells, identical cells, connected in series. In the form of a loop, all the cells are identical. You see this? There are n cells, n identical cells. सेल्स सारे आइडेंटिकल हैं, सारे के ईएमएफ ई और इंटरनल रेजिस्टेंस आर हमने इंडिकेट किया है, ईएमएफ एन आर. लेट अस सपोज यू हैव बीन गिवन 2 पॉइंट्स. कोई भी 2 पॉइंट हमने उठाया है जो सेल्स के एंड टू एंड को ज्वाइन कर सकती है. These are the 2 points. Let's suppose B and A I have marked. And आपसे ये पूछा गया है कि what is the potential drop between point A and B. You understand the question? यहां पे n सेल आइडेंटिकल सेल्स की एक ग्रुपिंग है और उसमें 2 पॉइंट्स हमने यहां पे ऐसे कनेक्ट किया है, which is the end of this cell and which is the end of these 2 cells. जहां पे भी 2 सेल्स ज्वाइन हो रही हैं उसको पॉइंट बी लिखा है, यहां पे भी 2 सेल्स ज्वाइन हो रही हैं उनके पॉइंट को हमने ए लिखा है. एंड आपसे पूछा जा रहा है कि व्हाट इज द पोटेंशियल डिफरेंस बिटवीन पॉइंट ए एंड बी. नाउ सी, टू सॉल्व दिस क्वेश्चन you must agree that all these cells are in series and they are supporting each other. For that matter, the current which will be flowing in the circuit, current जो सर्किट में फ्लो करेगा, that will be net EMF. net EMF की जगह पे हमने N into E लिखा है. Why we have written N into E? Because all these N identical cells are having same polarity. That is why we have written N into E. And what is the equivalent resistance of the circuit? Equivalent resistance is N into R, because each and every cell has internal resistance small r, so total resistance is simply added, and the current which is flowing in this circuit you can make out. This is E by R. And now let us concentrate on a single cell. What is happening to it? You are clear about this fact that current I is flowing in the entire loop throughout. And now just concentrate on a single cell. We are trying to highlight this fact that potential drop across any cell is 0. EMF is there, internal resistance is there, and the current is also flowing I. We are trying to find out what is the potential drop across a single cell. Now you see, if the current is flowing like this will be at higher potential and this will be at lower potential. this will be at lower potential and this will be at higher potential. So the potential drop, if you calculate, or terminal voltage across a cell, will be here first minus IR. Why minus IR? V across, that is terminal voltage across a cell, is, we are saying minus IR. Why minus IR? Because you are moving from plus to minus, from higher to lower, and then you are jumping across this EMF, then it will be a gain of plus E. You see this? And in case you substitute, now if you substitute the value I is equal to E by R, जो सेल के क्रॉस, एक सिंगल सेल के क्रॉस टर्मिनल वोल्टेज है, उसके एक्सप्रेशन में I की जगह अगर आप E by R सब्स्टिट्यूट करें, then this is minus E by R into R plus E. This is minus E plus E. So this will be equal to 0. This is what we wanted to highlight. We wanted to highlight that potential drop across each cell is 0. You understand? ऐसा नहीं है कि EMF 0 है. Current is there in the circuit, EMF is there in the circuit, but the terminal voltage across each cell is 0. अगर ये यहां से यहां तक 0 है, तो यहां से यहां भी 0 है. It is 0 from here to here also. It is 0 from here to here also. That means अगर आपने इसका potential 0 volt लिखा, then 0 volt is here, then again 0 volt is here, 0 volt is here, 0 volt is here. This point is also at 0 volt. This point B is at 0 volt and point A also at 0 volt. So if you are joining it by any voltmeter, the potential drop obtained will be 0. So your final answer will be 0 volt. You understand? So this is an interesting result you have obtained, that in case n number of identical cells are connected in a loop like this with same polarity, then potential drop across each cell will be 0. And if you try to check the potential drop across any two cells, that will also be 0. So that is all in today's lecture. Now before we move ahead, let us summarize what we all did in today's lecture. In today's lecture, first we looked at the basic notations of a cell, in which we talked about what is the meaning of EMF, what is the meaning of internal resistance, what is the meaning of terminal voltage. We said that these two are constant and terminal voltage may vary. We said that V can be E plus minus IR. Terminal voltage can be more, terminal voltage can be less. It can be equal to EMF. All three possibilities are there. Then we said what are the implications of cells in series, in which we said that if EMF are in same polarity, they are added. If they are in opposite polarity, they are subtracted. But internal resistance is always added. Then we discussed cells in parallel. There we said that generally we give you the question in which all the EMFs are same and equivalent also is a single EMF. Then we discussed mixed grouping. In the mixed grouping of cells, a very interesting example of eelfish, electric eelfish. And at the end, we highlighted the entire concepts with various numerical examples. So that is all in today's lecture. Now in the next lecture we will discuss various aspects of ammeter, voltmeter, potentiometer, etc. Thank you.